of height h with the speed vi and angle theta. How fast is the rock going when it hits the ground? And what happens to your answer if you change theta? So pretty much we're going to be using the conservation of energy formula, and it's mgh plus 1/2 mv initial squared equals mgh plus 1/2 mv final squared. And since it's gonna go to the floor, that just takes out this height because it's gonna be 0. So you pretty much are gonna solve for v final here. And since you have all m's, you can pretty much distribute this m out and cancel all the m's. So the m's cancel out. So you're left with gh plus 1/2 vi squared equals 1/2 v final squared. If you multiply you have to give you final alone, so you're going to multiply 2 over, which becomes 2gh plus vi initial squared equals v final squared, and then that just becomes v final equals the square root of 2gh plus vi squared. And we kind of have, since it's asking us for theta and the angle, we have to find out like h with the drawing here. So this is where MS is going to take control.
Right now, but now we kind of want to replace this height with something that we can relate to, like with respect to y. So here we have our new h of y, our new height, because we're starting from high up. It's going to be u sine our angle, which is thrown, times time, plus 1/2 gravity times time squared. More clear. So now we're good to go. We just have to plug in this h with respect to y into this final VF formula. So VF is equal to square root, need a lot of space for this, 2g, plug it in. Oh, and I forgot to mention this u right here is nothing but our VI with respect to that y. So now we're good to go. VI with respect to that y, sine our angle at which it's thrown, times time plus 1/2 gravity times time squared. And we also have one more, VI plus VI squared. And then this one right here is with respect to x. And so now the second part of this question is asking how the angle, like how it's going to affect everything. So we can just go ahead and imagine this unit circle. Here we have 180, we have 90 here, and then we have 0. So we know here that this is changing from 180, and this is all like in degrees, from 180 to 90. We see this increasing, and then it's going to decrease from 90 to that 0. It's kind of backwards, but you can kind of see how, like, if you were to throw a ball flat or a rock flat, it wouldn't go as far as if you were to throw it at these angles, 45 and 135. So these two angles right here are for like the maximum like length you can get it in the x direction. So this is our final VF. All we had to do was just plug in that h, and now we're good to go.